Okay, now we are going to continue the topic of domain modeling. So, the reason for a technician, a programmer to tackle with an unfamiliar domain is that those technician knows how to use solution domain, the technique of solution domain to solve it, right? So that would be you, right? So you should know the technique related to the diagram, right? So one of that will be diagram. So with the diagram, then we can communicate. We may understand from the diagram about the overall of the application, all right? So if we are going to design a campus application, then we should talk with our client, right? That could be staff of the university or general school about the process, right? And model that. So one of that is to know the overall structure, right? So the structure, even though the structure is static, but it helps us understand the relationship of the classes. Of course, the classes will be the most important one that we wanted to write our program, right? We have already discussed the association of classes, right? So from the requirements, and we can write use case description. A use case description helps us to understand probably a function, right? A function that how it goes, and the function communicates with other functions, right? So that will provide us an overall of the system, right? So a system, we use case diagram, right? So use case diagram has a couple functions, but the functions will be described by each use case. And the use case communicate with other use cases, probably include or extend, right? Or if we just begin, then we provide an overall, not so clear requirements, then our use case could be broader, right? And you will see the hierarchy, so it's a generalization and specializations of the use cases. And then you find it out some use case has communication often, right? So if that is so, we might take out some common part also included, or no option. So which you have already understand that. From a use case, we wanted to draw the concept, right? The concept that would be the templates. Template talk with other templates. So it's class talk to other class. It is static diagram, right? Then we wanted to understand more about that. Then we can write the program. Know the associations of classes, right? So association that it's a relationship, right? Relationship of the classes could be I said as a hierarchical, right? And then expand it. Some classes has an association with other classes, but for the classes itself might have hierarchical. All right, so you're going to expand their relationship. It could be inheritance and some of that association. And last week we talked about inheritance conflicts, right? So inheritance conflicts, we need to think twice. If you wanted to implement inheritance, you think about that because a child depends on parents. So whatever parents have, they will, you know, they will pass this on to the children. So if a child actually is not suitable to have the parent's friend, then you're going to have trouble, all right? So there will be kind of, you know, misuse of inheritance. So not because you think that a class, you know, extend other class, well, that could be inheritance. I said to think twice. So you got to think about if your parents has an association with other class, you also need to, you know, make friend with your parents' friend, all right? If a child has no relationship or is not suitable to have this kind of association, there will be a problem, okay? Or we also talk about the multi-level, all right? Parents passes on to the child, and child also has child, right? So it's multi-level, right? That could be of trouble, right? So if you go deep, then grandchild depends on, you know, parents and parents and parents, right? And the overrides, they might have trouble. Or multiple inheritance. Some programming language, you know, allow to have multiple inheritance, but they have other procedure to handle that. In Java, no, does not want you to have multiple inheritance. And last time I asked you a question, the student answers correct, right? So if you have two parents and they have the same attributes or operation, and which one, you know, you wanted to inherit that from, right? So there was trouble, right? They will have inheritance conflicts. And today we'll start from a more restricted inheritance, right? So it tells us that they always wanted to use inheritance, think, you know, more about the afterwards, you know. So when we inherit your parents, then that is a principle. Let's call it substitution principle. So we're going to talk about this, right? More restricted. So it says that, well, since inheritance has a lot of problem, so provide one principle. That principle, you know, help you to confine your scope, right? Don't misuse them. So if you wanted to use inheritance, think that a child, will the child, you know, will the child replace your parents? If that's so, that meets the requirements of LSP. So let's see LSP. This scope substitution principle, right? This scope is the last name of the initiator, this principle, all right? This scope, Barbara, this scope, right? So this scope substitution, want to replace, right? Substitution principle, so the principle tells us that if you wanted to apply inheritance, then the child can replace, can substitute for the parent, right? Very strict, right? We know that child depends on parents, right? Child depends on parents. And the substitution that child can replace parents, right? But anyhow, you use the inheritance, then child want to replace parent, but it happens no, because they have some different operation, or the attributes not appropriate. Then it violates against the principle, right? So parent has anything, then it wants that, well, I want a new child, so I suppose child can replace me, right? But what if it cannot? Then against, so violates LSP, right? So here we have an abstract duck, right? Abstract duck. So the duck is going to be implemented. Some of the method will be implemented by children, right? So we have concrete duck. So concrete duck, we may have different kinds of concrete duck, right? Even include rubber duck. It's not a real duck, but just look like a duck, right? And here is that, well, a duck can crack. So all the duck, of course, inherit from the parents. So all the children can crack, right? Of course, the children can have their special features, special method, right? If we don't use fry the method, right, in abstract duck, the concrete duck can add, right, can fry, right? But here's the thing, that since abstract duck and concrete duck have the same method, crack, right? So parent has crack, a child does not need to write crack because automatically will inherit crack, right? But the child has another method, fry. Fry is okay because, a child can expand that. But crack, abstract crack may define the crack method, right? And of course, the concrete duck might override it, but it goes more than that. Or the abstract duck, we have attribute, right? So attributes, the duck know something, then they can crack, right? But it happens that concrete duck is different way. Then abstract duck will be surprised when the duck creates the child and the child behave differently. Then, well, it goes wrong. Goes wrong doesn't mean the code is wrong, but it against LSP, right? Let's say that's Liskov substitution principle. So it says if it looks like a duck, quack like a duck, but it needs battery, right? So it needs battery. You probably have the wrong abstraction, right? Because the parent does not, need to have the battery to crack. So it says if you wanted to apply inheritance, then it's quite restricted, right? Then it may go wrong because rubber duck may not a child of the real duck. If a program module is using a base class, then the reference to the base class can be replaced with the derived class without affecting the functionality of the program module. So here, what is base class? The parents and children, we talk about substitution principle. What is the base class? What is the derived class? What are the differences? don't know that, so that means you don't understand ASP. What about you, Bill? Base class. What does it mean? Explain this. Base class, derived class. Jimmy, base class.
Base class is like the parent class, and divide class is the children class.
Okay, good. Again, really. Which one is S? Which one is T? Base is T, or derived is T. Last time I told you that not just come here and sit. Base class is a type of T or S. Still cannot follow. Okay, but
Base type is T. Yeah, and subtype is S. Yeah.
okay, good. So here, it said that child is a parent. Is a kind of parent, right? Is a kind of parent. So if you have a parent class as an animal, so the subclass is a kind of animal, all right? So that's what we know. But here it says it's substitute, right? It's can be substituted. Parent can be substituted by a children, right? So children, can substitute for parents. So here, substitutable. Is become is substitutable for, right? So child, right, can substitute, right, the parents, or the parents, right? That here, that's you have this, file, I think. So now we have, we wanted to describe relationship between two classes, right? One class is rectangle. So we have two classes. One is rectangle, the other is square. They all have size, four size, right? So rectangle, right? So, sorry. Since they have four sides, you probably think that, okay, we wanted to use inheritance. So we have a rectangle, and then we wanted to create a square, right? So you use inheritance for the size, but for the height and width, right? Width and height, right? So for so two sides are the same, right? We have height and width. That's the attribute. Since rectangle has height and width, knows these two attributes. So we give it an area, get area, or calculate area. Know something then can calculate area, right? Can do something. And then we have square. Suppose that's square. No, we have four sides, height and width. But for square, actually, no, they're the same. The square doesn't need to define height and width. But since the parent, no, parent has this, so got to follow, right? So follow that height and width. But we need to override this because I said define it the same, right? We got to define width is the same as height, right? There's a square, so we need to define that. So now we see that why we said that it violates this cup. So we have rectangle, right? And we define width and height, right? So we can set and get area. Know the thing, then do the thing, all right? Know something and do something. We can get area. No, times width time height, all right? Since we use inherent square, extend, rectangle. So of course we have everything, right? We can set width and set height. Now we need to override it, right? So override it. Since we said width and height, but they are the same, right? So we need to set it as width, is equal height, right? And the other, we set it again, all right? So it will be different if you set which one you set first. Then now rectangle, get new rectangle, right? A new square. We need a child. Okay, so here we set width because we wanted to new the square. We set width and height. All right. So Leo, what would be the result? 50? Why was it 50? Because time, it says width times height, right? So 5 times 10, so it would be 50. So you suppose should be 50, right? Harry, yes or no? The result,
So it's 50.
50?
Yeah.
Do you think it's 50?
Yeah.
That's what
Because
we expect should be 50?
Yeah.
Right. Does anyone say no? Harry? Harry?
We accept the 50, but the result is 100
100? Why was it 100?
because it's two, it's square and rectangle.
Say it again.
Uh,
Because
we expect the result is 50, but this one's result is 100 because this one is square, one is rectangles.
one is square, one is rectangle, I don't understand.
Sorry, the set height is 10, so 10, 10乘10，所以会变成100。
Say it again. It said one is square, one is a rectangle. This part I don't understand. I don't get it.
I think the one is rectangle, one is the square is wrong. 我说错了。
Okay, then no.
It's because the set height is 10, so the square is will 10乘10，然后变成100。
Okay, so we expect 50, but no, it turns out will be 100. All right. There's nothing wrong for the code itself, but the expectation, no, that's not what we expect. All right. So scenario, how can we make it as 50? We expect that to meet our expectation. Probably the question to you is not clear.
Our set width is 5 and our set height is 10 and the result is 50.
No, I said that here we know it is violate LSP, all right? So any situation that it could meet, the rectangle, needs. Rectangle said, yes, or it can fool a programmer fine. That's the result. Result is 50. If result is 50, it's fine.
Sorry, I didn't get the...
Any situation, the result will be correct. Any situation, the result will be correct. We need to change something. What we can change? Or anyone tell me that the results. We need a result, right? That will be correct as a 50. Think. Okay, Bridger?
Could we scroll up to see the get area?
Get area.
I need to scroll up.
Scroll up. Get area.
Yes.
Then?
And I think if we want to get 50 and
No.
because
No, it says that's the result here. If it's a width, the height, all right. The result is 50. Then we should change the code.
we should not return a new square,
Then
a rectangle.
good. Very good. So here, if it new rectangle, the result will be 50, all right? So we have no idea, here. So we might, for the rectangle itself, now it's a new, it's a returned here. Get a new rectangle, return rectangle, right? Of course, the result is what's the rectangle expect. But now we cannot new the child. You got it, Harry? Right. So if a new child, then we said that we change that. All right. We override it. Then it become 100. Bridger, what if we didn't change that, but result become, is it possible become 25?
25.
Yeah.
If we set the calculation of the square function, if we set the height equal to the width, we could get 25.
Say it again.
We return a square, right? And if set, can we scroll down again? Thank you. I have to write it down so I can set with 5, set height 10, and we wanna get 25. Can we scroll back? Thank you. So we are in a square function, and if we want to get a 25, we have to change the n width equal to width and the height equal to height. So we can get 5n. What should I say?
Anyone wanted to answer this? Okay, Jenny? Penny? Yeah.
The simple one to get 25 is that, please scroll down. Thank you. The simple one is the R set height to change to 5, and the Richard mean there will be width equal height equal 5. Is Richard?
So you said that we change height as 5
Yes. It's
and
simple one.
width as 10 or 5, 5.
5, 5.
5, 5.
Yes.
So you say 5, 5.
5, 5, 25.
No, that's not what I expect. No.
What? I
Not
don't.
what I expect. Because when you change 5, 5, no, we don't need to discuss this case. Whatever, you'll be 25, whatever, right?
Yeah.
No.
Oh. Then it's the Richard mean. It said the square function width equal height. Yeah.
Say it again.
The set function width equal height.
Width. So here, height, right? So with the width and height. So width the same as height, and height the same as width.
Yeah.
Carol?
Can I check the question is how to from 100 to 25?
Yes.
And I see the function of square. I see the set width will try to width and height all change to the width. So
All change to the width.
yes, and the height is all change to the height. So if I try to exchange the main function to
Main function.
to first I execute the R set height, and next we execute the R set width, and the result will be 25.
Okay. And here, if we reverse that,
Yes,
that's okay.
and
And we said that, you said we change this part,
yes,
right?
yes,
So set width becomes set height,
yeah,
all right? So we set height here.
mm,
We can see that we set width first.
okay. And if I try to, if set width first,
So it doesn't matter.
yeah,
It doesn't matter.
mm,
How to do it?
and it's okay if I try to the set width function and the code try to all change to the height.
Set width,
Yes,
all
So-
change to the height.
yes,
So width, yeah, width change to the height.
yes,
And here, height change to the width.
yes,
So here it says width change to height.
Yes.
It's already width change to height. Ken?
I think I have a solution. First, we can rewrite the square like with set width or just set width, not set height. Just set width, and
Just
set
set
height is only set height, and we can
set width. What do you mean set height is only set height? So take it out.
check it out, and we override the area. We make the square area is wide times wide, and the answer will like
This
this.
is at 5 and 10, right? 5 and
Yes,
10.
and the set height will be useless. So you only set the width. And you have the width and the height, but the calculation only use the width. So in this case, you can keep this code and get the area is 25.
So we only set width,
Yes,
set width.
yes.
And then, but here set height, you should do something. Set height. It says you take out the body. Set height, nothing.
Yes, it's,
But set height, you need to do something, right? You're not going to leave it blank.
or maybe we just delete the code about set height under the
No, that's not reasonable, right? So here we have square, right? Set width and set height, right? You need to put the body inside, right? You cannot leave it blank. So set width. So here, if you reverse that, right? We set height and then set width. Everything will be width. So here, whatever you do that, right? Everything will be width. So the main part will be here, not here. All right. So, but that is to tell you that it violates LSP because you gets trouble about that. Square got to be the same since parents will be different. All right. So we need to set it the same, right, for square. But if rectangle, new a rectangle, we do nothing. But with square, we need to set them the same. But the key is that which one you set it first, right? If you set width, then set height, right? Or then set height and set width, then they will affect this part. It doesn't matter you set it first or later because follow this part. But it violates principle, right? And so here, of course, since it violates LSP, so we need to think that, well, we're not going to do that. Square cannot substitute rectangle, right? Because rectangle, does not, have the same size, right? So when we wanted to calculate area, then, well, rectangle new, since it's parent new the square, the result, is not what rectangle expect. So it violates LSP. And now, they said, okay, since it's not good, we got to change that. So we change this. What about, right? So we think that's square. So we change another broader one, right? We change another one. Whatever, it's a 4 size, all right? 4 size, could be anything, right? So we change quadrilateral. We change to quadrilateral. 4 size, right? Well, that's okay. Rectangle is a kind of quadrilateral. So is square. Square is a kind of quadrilateral. Will be okay to meet LSP or no? Rectangle is a kind of quadrilateral. Square is kind of quadrilateral. Is this okay to meet LSP? Yes or no? Mary? Yes? Why? Why is it yes?
I think rectangle and square can also replace the quadrilateral.
Can replace that?
Yeah.
So, oh, what makes you think so?
Because even because the quadrilaterals method, the rectangle and square extend the quadrilaterals method, but didn't change it. It just extend and expand. So I think both can replace the quadrilateral. So
So-
it's the LSP.
What if quadrilateral wanted to new a square? So quadrilateral wanted to new a square. Can quadrilateral new a square? Yes or no?
Yes.
Yes, then
And they can, the square can use the quadrilaterals method.
so it presumes that quadrilateral will be a square. Because the child is a square, so square can replace quadrilateral.
Yes, I think that.
Of course, no. They're the same. The problem is still the same. Quadrilateral doesn't mean that, we have height and width, right? The same. So quadrilateral wanted to new a square. The problem still there. No. Still violates LSP. Then how to solve it? How to solve it? We discuss in a group and work it out and write the code now. You need to think about that. I'll give you the hints. It's related to polymorphism, right? Yeah, think about last time, polymorphism.